Okay.
So we have now a talk by Adalto Gomes from Universidad Federal do Maranhão, and he will talk to us about scattering of S2 kinks. So please.
Okay, thank you for the invitation to be here. Indeed, what I plan to talk, fortunately, is not quite related with what's the main issue of this meeting. The, maybe I could say there are some connection concerning to an induced metric in the internal space. But what I will talk is about some simple systems in 1+1 dimensions. So what may be of interest for you is that I will talk about some simple systems and how some complexities can be simplified using the internal space. It's only this message. So this work was done in collaboration with Fabiano from the same university as mine. These are the financials. Um, what I want to talk so is a brief introduction and then talk about the nonlinear O3 sigma model in 1+1 dimensions and talk about the geometric and direct coupling. What I want to present is some kind of extended sine-Gordon model and how to present these scattering results in the internal S2 space. So the idea is to talk about topological defects as some kind of field theory solutions that propagate without losing form, so they are stable. Uh, in such case, there are some kind of topological map between the physical space and the internal space. As I said, there won't be gravity here to be a system in 1+1 dimensions. And the simplest solutions we call kink and anti-kink. In high dimensionality, we can consider a kind of a multiplet, and in such a kind of geometric constraint, constructing this nonlinear O3 model. When coupled with gravity, there are a paper with Carlos Herdeiro and collaborators where they consider such kind of black holes with hair. This is the only point of contact with what I will say. In 2+1 dimensions, there are such kind of mapping of S2 to S2, but they are unstable. But even with this, they can investigate scattering because they are unstable, but they can live a quite longer time. But in 1+1 dimensions, they are stable and they can be studied. But in internal space, they are such kind of non-contracted loops. There are several works with quadratic potential, and also the idea is to use the spherical coordinates in this S2 internal space to describe the system. The idea to consider fields in curved space can have some kind of motivation in string theory and bubble universe collisions, where in this way I choose to study this system. So what's the idea? The idea is to consider a multiplet of free fields. And when I describe this in a sphere of unitary dimensions, I can translate this 1 plus 1 action in this one, where now I have an induced metric depending on the fields. And then I can also extend this, the former action, considering a direct coupling with this potential. And then the equations of motions are such kind of coupled system. The scalar static solutions are still coupled, but then if I propose a potential of this form, the equations of motions that minimize the energy density can have this extremely simple structure. The stability analysis is extremely complex, but for such kind of model that I will consider, this can be decoupled and find a kind of probabilistic interpretation. So what's the idea? The idea is to consider a function such that with this function, I recover this complicated potential. Why I choose such kind of potential? The idea is the following. With this choice, I can obtain a solution for one field in a kind of simple kink of the sine-Gordon model. And the other field, the field chi, has such kind of a loop, an anti-looping profile. The energy density for such kind of parameter C can have this kind of one peak structure or this double peak structure depending on this constant C. So now, what is this kind of solutions in internal space? Since the sine-Gordon model, the sigma model in internal space is a sphere, the kink or anti-kink are kind of loops in this internal space. And when I consider kink anti-kink to scatter, the structure of the partial differential equation must be solved with this kind of internal initial conditions. And for several different set of initial conditions, I can consider kink anti-kink or lump anti-lump scattering for the other field. Now, what's the idea? I will show you, if I could, a kind of video. I don't know if I can hear. Probably not. No. I tried in the other notebook, it worked. Oh, it's here. So you can see here, this two first picture show the scattering for the two fields, the field phi and chi. They behave as a kind of complex way, but in internal space, they develop a kind of loop that evolves until achieving the vacuum. All kind of scattering can be described in this internal space in the simplest way. So, for instance, in this case, loop in the northern hemisphere and another loop in the south hemisphere, consider a kind of kink-anti-kink set. They evolve, the field phi change the orientation, and the field chi changes. And what's the idea? The field phi is considering the angle in the equatorial, and phi is the angle from north to south. So the idea is the following. These loops can develop such kind of interconnections when they scatter. And the numerical solutions for this set depends on this constant C. And what I do is to relate this constant with the property of integrability or not of this model. So in one of this case, this model that is non-integrable show during the scattering behavior near to integrability. And this can be seen in the internal space with a more direct way. That's the idea of the work, okay? Thank you.
Thank you very much for the talk. Are there some questions? I must say that I did not come up with a question myself.
No problem.
It was so another chance for questions from the audience. Okay. Well, thank you again very much for the talk.